Our question for Module 8 Quiz B number 2 is, your image created by a flat mirror appears blank because blank. So our answer choices are in front of the mirror because your eye imagines the reflected light travels to it in a straight line, or in front of the mirror because the light approaches the mirror with a large angle of incidence, behind the mirror because your eye imagines the reflected light travels to it in a straight line, and finally, behind the mirror because the light approaches the mirror with a large angle of incidence. The main components of each of these answer choices are where the image is located, either in front of the mirror or behind the mirror, and why we see it like that. So what are the main two parts of this question? One is that we are dealing with an image, and second is that we are working with a flat mirror. So what is an image? An image is something seen by the eye that resembles the object. The image is created by light after it interacts with an optical instrument. Images can either be real or virtual and can have the same or opposite orientation compared to the object.
Hello, this is Sahar. So the first principle discussed is an image appears wherever light rays intersect after interacting with an optical image. So in this case, the optical instrument is the mirror. So moving on to the next slide, in the Module 8 first check, we see this idea regarding intersecting light rays. So question 15 asks, an image occurs when your eye perceives light rays to cross. This is based on the assumption that light travels in straight lines from an object to the eye. So the answer to this question was true. So the key takeaway from this question is that light must travel in straight lines to the eye. So moving on to the next slide, from this Module 8 video is where this principle can be better explained. So I'll play that really quickly.
I think that this light came from. So remember that light always travels in a straight line unless it interacts with some kind of an optical instrument. So even though your eye sees this mirror here, it still imagines that this light, which just go ahead and draw this light that's getting to your eye, it still imagines that this light gets to it by having traveled in a straight line. And so your eye calculates that this light is coming from behind the mirror because that's what's in a straight line. And
this practice example is done to show the path of light rays as they leave the object, so the arrow, and then reflect off the mirror. So it shows us that the image is located behind the mirror because the reflected rays continue straight and seem to interact behind the mirror, as there are no real light rays interacting in front of the mirror.
And now I'm going to be explaining why the concept of an image produced by an object actually eliminates the first two choices. So our eyes only perceive light coming in from as straight lines. So when an object produces the rays that interact with the mirror and then get reflected off, our eyes perceive the reflected rays to then travel behind the mirror, then interact behind the mirror to produce that object.
So knowing that we're working with a flat mirror means that we can use the law of reflection to calculate the path of light rays based on the angle that they make with the normal. The normal refers to the line perpendicular to the plane of the mirror. The law of reflection states that when light is reflected from a smooth surface, the angle of incidence is equal to the angle of reflection when measured from the normal. From the Module 8 first check, we talk about the phenomena of total internal reflection. This is when light shining into a new medium doesn't go through and rather is reflected completely back into the original medium. The way we measure this angle of reflection is based on the angle of incidence. The critical angle is the angle of incidence for which the light fully reflects. Anything larger than the critical angle has the same effect. So in this example, we have to use the law of reflection to relate the two angles, but not by using Snell's law nor the absorbance criteria. In the Module 8 pre-class video called Mirror Principal Rays, the law of reflection depicts both the incident and reflected rays as symmetrical across the normal.
Which is the angle between the incident ray and this normal line, then the reflected light ray will make an angle theta reflected with the incident ray such that the angle of incidence is equal to the angle of reflection. So this law of reflection, statement of symmetry, gives you a picture that you probably can imagine if you've ever used a laser pointer and shot it at something where you could see the light reflect, or even not a laser pointer, just any other light if you're looking at the reflection, for example.
But in order for there to be symmetrical reflection, there's an assumption that we have to make. We have to assume that the surface is smooth. A smooth surface will allow for specular reflection, where reflected light is observed to follow the law of reflection. But if the surface is rough, it will still obey the law of reflection at each point on the surface, but because it's uneven, this causes the light to reflect in different directions. This is diffuse reflection observed only at the microscopic level, whereas the angle reflection off of a smooth surface can be observed at the macroscopic level.
So for the last problem or answer choice D, behind the mirror, the light approaches the mirror with a large angle of incidence. Why this answer choice isn't correct is because the law of reflection allows us to eliminate this answer choice, because a large angle of incidence that approaches a surface will lead to a large angle of reflection. And then this does not explain why the image appears to be coming from behind the mirror.
Back to our question for Module 8, Quiz B number 2. Answer C is the most accurate and describes both where the image is and why it appears there. So your image created by a flat mirror appears behind the mirror because your eye imagines the reflected light that travels to it in a straight line. While the light directly reflected from the mirror would not be able to create a real image, your eye still imagines one by following the straight path of the light rays.
So ChatGPT also got the quiz question correct as well, and it uses a logic that light rays travel in a straight line that appears to begin from behind the mirror. So our brain interprets the direction of the light as beginning from behind the mirror. So we know that logic that ChatGPT uses is similar to the example problem that we talked about earlier, where we trace the reflected light rays behind the mirror until they intersect.
So I'm going to be going over practice question 1, and this is one of our 2 practice questions. The first one where ChatGPT got it right, and this practice question was a definition-based practice question relating to the first principle we highlighted, object and image. And this was an important principle in our quiz question, and more specifically, when an object is placed in front of a flat mirror. And we thought this question would help students understand the real and virtual images as well as orientation. Which answer choice best describes the image formed by a flat mirror when you look at yourself in a flat mirror? And the answer choices are virtual and inverted, real and upright, and virtual and upright. So the correct answer for this question was D, virtual and upright. And that's because when you look at yourself in a flat mirror, the image formed is a virtual image. And the light rays don't actually converge at the location of the image, but instead, the image appears to be behind the mirror. And the light appears as though it is coming from behind the mirror and travels in a straight line to your eye. And this light does not actually come from behind the mirror, but your eye perceives it in this way. And this is known as virtual image formation. And also the orientation of the image does not change in the flat mirror. So your image will remain upright when you look at yourself in the mirror. And then let's go over the other incorrect answer choices. So for answer A, virtual and inverted, it's incorrect because images in a flat mirror appear upright and maintain the same orientation as the reflected object. So when you look in a mirror, a flat mirror, your reflection will be the same orientation as you are. And then for answer choice B, real and inverted, a real image is formed when light rays converge at a specific point and can be seen at one location. But in the mirror, the light rays don't converge at one point. So that's the definition of a virtual image. And also the flat mirror's reflection is going to be upright and your image will not be upside down when looking at yourself. And then for C, real and upright, again, the image will not be real because the rays do not converge at one point, but instead the image reflected appears as though it is behind the mirror. And then this is ChatGPT's answer for our question. So it got it correct. In a flat mirror, the image formed is virtual, meaning it can't be projected on the screen. So your image will actually appear behind the mirror instead of on the mirror. And your image will be upright. So it'll have the same orientation as you are when you're looking into the flat mirror.
So now I'm going to be talking about practice question number 2. This type of question is an application type of question. So this question was created by both Kylie and Alex. It says an object is placed 2 centimeters in front of the focal point of a mirror that curves inwardly. The image produced is blank, the mirror, and blank. So our options are A, the image is produced in front of the mirror and inverted. B, the image is produced in front of the mirror and upright. C, the image is produced behind the mirror and inverted. Or D, the image is produced behind the mirror and upright. So the correct answer is actually D. This is due to both the concepts of image and object and also the law of reflection, which we just went over. So it says here that the mirror is curved inwardly. That means that the mirror is concave. So when an object that's outside of the focal point, its incoming rays when they interact with the concave mirror, the reflected rays are then interact at the focal or intersect at the focal point, and then they produce an image behind the focal point that is inverted, and in front of the mirror. However, when the object is placed in front of the focal point of a concave mirror, their incoming rays don't particularly interact the same way as in a normal situation. So the reflected rays, don't intersect with one another to be able to produce that inverted image that's in front of the mirror. What actually ends up happening is, because our eyes perceive light in straight rays, it traces back the reflected rays to behind the mirror and produces that image. And the reason that it's upright is because the top incoming ray that from the object, when it's reflected, the reflected ray, when you trace it back, it's still on top. And that also applies to the rest of the incoming rays from that object. And when we asked ChatGPT, it actually answered this question incorrectly. It said that the answer choice was C instead, behind the mirror and inverted. Though it got the image produced will be behind the mirror instead of in front of the mirror, it thought that it would be inverted and not upright. So yeah, it got it wrong because we know, due to those principal rays, that the image produced behind the mirror is upright. Because the angle, our eyes trace back those angles of reflection to produce that image. And that is all for our presentation. Thank you very much.